in Jupyter in your web browser, this is what you're going to see. Now, some of these commands are slightly different for a Macintosh and for a PC. I'll point out when that's the case. And some of them are slightly different if you're using Python version 2 versus version 3. Also, if you've installed Anaconda Continuum, a lot of packages come installed with it, but in case you don't necessarily have all of those, we're going to manually install some of the key packages. So I'm going to run this command, pip install pandas, numpy, scipy, and sklearn. And actually it's telling me that they're already installed, so it doesn't hurt to do it this way. Once they're installed, we can import them. And then we can load some data. I've saved the data file to the desktop as b5.csv. Now, this is one where it makes a difference if you're using a Mac or a Windows PC. For a Mac, you can specify it this way with the tilde for the user directory and then desktop and then the name of the file. That's what I'm going to do right here. If you're on a Windows PC, you're going to need to do it slightly differently. And of course, where it says Bart, that's me, change that to whatever your home directory is called. But either way, once you get the data in, you can then convert the data to a NumPy array. We'll do that there. And then we're going to scale the values. That's a common thing when you're doing a principal component analysis. It's a way of getting all the variables on the same range that makes it so one doesn't overwhelm the others. That's a very quick and easy command right here. By the way, this warning just tells us it's converting things from 64-bit integers to 64-bit floats, and that, that's fine, doesn't matter. Then we're going to do the actual analysis. We're going to do a principal component analysis, and we begin with 50 components because we have 50 variables. So I'll come down here and run that one. And what it does is it shows us how much of the total variance each of these components explains. And you just have to know that it starts with number 1 and goes to number 50. And number 1 accounts for 16% of the variance. So that's a big chunk. And you see down by the time we get to the bottom, it's less than 1%. It's a very small number. But I'm actually going to specify a 5-component solution. And the reason I'm doing this is because I know that the data is supposed to reflect a 5-component solution because there's supposed to be 5 personality factors. So I'm going to do it that way, where I say the number of components is equal to 5. And here you see we have the same numbers for the first 5, and then it just kind of stops after that. Now we can look at how much each variable contributes to the components. I'm just going to run that right here. And we see that we have 50 variables, and for each of those, we run through them for how they contribute to component number 1, component number 2, and so on. Now, the unfortunate thing, and this is really about as far as we can easily go with principal components with this particular package in Python. It's only numerical. It's very difficult to get graphics, basically impossible. And what this suggests to me is that while Python is extremely well developed for a lot of data science tasks, some statistical tasks like principal components analysis, it's not quite there yet. I'm sure that as it continues to develop really at an exponential rate, it'll get that functionality soon, but not quite ready for prime time in this respect. Now, you should know that you can launch